Okay, here we go. Practice problem 6, lesson 9.3, part D. Okay, so this time we're going to take a look at 6x squared minus 4x equals 1. So one more time, we're going to have to go in here and solve that for 0. In other words, set it equal to 0. It needs to look like ax squared plus bx plus c is equal to 0. So that says this will be 6x squared minus 4x minus 1 is equal to 0. So that gets us a way to quickly, hopefully, identify our a, b, and c. We see a is equal to 6, b is equal to negative 4, and c is equal to negative 1. So that tells me that x is equal to the opposite of negative 4, which is opposite of b, okay, plus or minus the square root of b squared, which is negative 4 squared, minus 4 times a, which is 6, times c, which is negative 1, all over 2a, so that's going to be 2 times 6, okay? And as in the past videos, I'm going to come over here and delegate the duty of calculating the discriminant to the calculator. So let's come over here after we do that part. Get over to the calculator here. Here we go. So second quit. Clear it out, and we're going to put in parentheses negative 4 close parentheses squared subtract 4 parentheses 6 close parentheses open parentheses negative 1 close parentheses, and we get back 40. Okay, so now that tells us that our what's under discriminant is going to be the square root of 40. So let's do a quick little aside here, and let's go see about how to simplify the square root of 40, because that may be a little bit rusty for some of you. So the square root of 40 is going to need to be simplified. Excuse me. To do that, what I'm going to have to do is break that up into two numbers. And the way we want to break that up is we want to break it up into something squared and something that is not. So I see 4 as a square number, so I'm going to write that as 4 times 10, where 10 is not a square number. When I mean a square number is something like the square root of 16. We know that comes back out to be equal to 4. Or the square root of 81. We know that comes back out equal to 9, okay? So once I've done that, I can use a very cool property of square roots that says if you have the square root of a times b, then that's equal to the square root of a times the square root of b. So we'll apply that here, and that gets me the square root of 4 times the square root of 10. Square root of 4 is equal to 2. Well, square root of 10, we're just going to leave that alone. That's just going to stay as a square root. Okay? All right, so we're going to take that newfound version of the square root of 40 and bring that back over here. And we're going to write this as with that version of the square root of 40 in it. We'll take a moment first to recopy it over here using the square root of 40. So that's going to say x is equal to 4, take the opposite of negative 4, plus or minus the square root of 40, all divided by 12. Okay, cool. Now let's go get our newfound friend here when we write down our x1 and our x2. So x1 is going to be equal to 4 plus 2 square roots of 10, remember that's what our square root of 40 was reduced, divided by 12. x2, that's going to be equal to 4 plus, excuse me, not plus, minus, Mike, make that a minus, minus 2 square roots of 10 divided by 12. All right, well, let's grab one of those and come back over to our side here for a moment to show you how we can simplify those a little bit. So if I have, back over here, if I have 4 plus 2 square roots of 10 divided by 12, and I want to simplify that, I'm going to come in and realize that I can take a 2 into all three of the numbers. Notice that there are three numbers here. There's a 4, there's 2 square roots of 10, and there's 12. And each of those are divisible by 2. So let's do that. Let's just take each of them and divide them by 2. So if we divide the 4 by 2, we get back 2. If I divide, we'll come off to the side here, 2 square roots of 10, if I divide that by 2, the 2's knock off, and I get back just square root of 10. And I'll take the 12 and I'll divide that by 2, and I get back a 6. And so as it turns out, going back to our newfound friend here, is that x1 is equal to 2 plus square root of 10 over 6. And similarly, x2 will be equal to 2 minus square root of 10 over 6. Whew. All right, that was very fast. You may want to watch that a couple times to make sure that makes sense, but let's go get our graphical solution real quick here. So to get our graphical solution, got to go to our calculator, go to our y equals menu, clear out that last problem out of there, and put in 6x squared, subtract 4x, subtract 1, and let's go ahead and try zoom in a standard. If we're in luck, they will have given us our zeros within the interval, and sure enough, looking like they did. So let's go check out one of them here. We're going to go second calc. I'm going to just go ahead and go for the intersection routine, make my life a little bit easier here. And we get negative 0.193712, blah, blah, blah. Okay, let's go get out of here for a second. Go second quit to get back to the home screen. Excuse me, second quit, not alpha quit. Clear this mess out here, and let's see. So we're thinking that was over x2 there. So we're going to go parentheses 2 subtract square root of 10. Close off that parenthesis, close off the numerator, divided by 6, and we want to see, is that the same as the value we just found? So we'll hit X again. Yeah, bada bing, bada boom. That tells me that yes, indeed, I am looking pretty good with my decimal approximations. Okay, I'm going to let you go ahead and do the calculator version of the second zero. That's the 2 plus square root of 10 over 6, and show that that works. But when you finish that, what you're going to need to do, of course, is come in here and give a reasonable sketch, a reasonable facsimile of what you're seeing on your calculator screen, and mark those solutions on here. So this solution right here was the 2 minus square root of 10 divided by 6, and this one over here is going to be the 2 plus square root of 10 divided by 6. And again, we're going from negative 10 to 10, negative 10 to 10. Okay, well, I know that was fast. You might want to watch this little segment a few times. I'm going to be back here one more time to show you that part E does not have any solutions in the reals.